Last episode, we designed Mint's financial aggregation. This one is the last episode of Season 2, the finale. We're not designing one specific system this time. We're going to walk the whole path, from one user all the way up to 10 million. And you'll see, scaling isn't one big move. It's one thing done over and over. Find the bottleneck, move it out of the way. Every time you clear one constraint, the next one pops up. That's the star of today's show, chasing the moving bottleneck. First, let's do the math and set a target.
10 million users, read-to-write ratio, 100 to 1. 40,000 reads a second, 400 writes. About 1 KB per write, 1 TB a month, 36 TB over 3 years.
The target's one line. Handle 40,000 reads and 400 writes a second. We climb the rungs one at a time and watch where the bottleneck goes. Rung 0. One box, the web and the database crammed together.
Tops out around 1,000 a second, nowhere near 40,000. The bottleneck is the box itself.
Rung 1. Move the database onto its own machine. Push the static files to object storage. Now each one can scale on its own. But the web tier is still a single box. The bottleneck's still sitting on it. Rung 2. Add a load balancer and hang a row of stateless web servers behind it.
41 servers. The app tier does 41,000 a second. Enough.
But notice, the bottleneck didn't disappear. It moved. Now it's pressing on the database reads. Rung 3. Add a cache, then add a read replica.
The cache absorbs 90% of the reads. The database only sees 4,000. One read replica handles it. Target met for the first time.
Rung 4. Autoscaling. The web tier flexes with traffic. Add at the peak, drop at the trough. So is the bottleneck gone now? Nope. It's just waiting for the next time the traffic shape changes.
Later, a write-heavy feature shipped, and writes jumped 10 times to 4,000 a second. A single write primary can't keep up.
Rung 5. Shard the database. 4 write primaries carrying the load together.
Write capacity climbs to 8,000. Target met.
Look at the whole path. Single box, to the app tier, to reads, to writes. The bottleneck kept moving the whole time. Scaling to millions isn't one big move. It's chasing that bottleneck with discipline. Let me slip in a point a lot of people trip over. Why can't you run a machine flat out? The server is just a queue, one service window. The moment the arrival rate closes in on the service rate, the wait doesn't creep up. It blows up.
80% utilization, 5 milliseconds response. 90%, 10 milliseconds. 99%, 100 milliseconds. From 80% to 99, the arrival rate only rose about 1.2x, but latency went up nearly 20 times.
So don't run any tier flat out. Keep headroom, around 70%, then autoscale on utilization and add machines before the knee in the curve. A tier running at 100% isn't full utilization. It's a latency cliff. Back to the cache for a second. It's the lever that makes millions of reads affordable. 100 to 1 reads to writes. Reads are a flood. The higher the cache hit rate, the fewer reads the database sees.
90% hit rate, and the database sees only a 10th. 95%, a 20th. No cache, and 40,000 reads need 10 read instances. A 95% cache, and 1 is enough.
Same load, and the database fleet shrinks to a 10th. The cache layer isn't optional. And there's a hidden bonus. Put user sessions in the cache, and the web tier turns stateless. And stateless is the whole precondition for autoscaling. Any request can hit any box. Add machines, drop machines, whenever you want. So where does AI plug into this million-scale picture? Here's the key. It doesn't tear everything down and rebuild. It hangs AI-shaped tenants into those same few slots. The cache slot. Swap in a semantic cache.
We actually ran 20,000 queries. Exact match hits 70%. The semantic cache maxes out 100%. Because it hits on close in meaning, not just on identical. LLM calls drop from over 5,000 to single digits.
The load balancer slot. Swap in an LLM gateway that routes by difficulty.
Simple queries go to a small model. Only the hard ones hit the frontier. Total cost comes out nearly 30% cheaper.
A vector store fills in retrieval. Learning to rank fills in ranking. All those AI layers from across the season, each in its place. The 4 questions. And we run the honest card right along with them.
What it helps with. The semantic cache saves LLM calls. The LLM gateway saves cost by difficulty, and the vector store and learning to rank fill in retrieval and ranking. What it replaces. Exact cache becomes semantic cache. A single big model becomes routing by difficulty. Keywords become vectors. What it changes. A few more AI tenants on the same skeleton, each one landing in a classic slot.
And what can it change? This is the season's last honest card, so let me hit the point. AI doesn't touch the stateless tier, doesn't touch the load balancer, doesn't touch read replicas, doesn't touch sharding, doesn't touch the queue, doesn't touch autoscaling. This skeleton is the thing it rides on top of, not the thing it replaces. The millions of users architecture in the AI era is that same classic diagram, plus a batch of AI tenants. The skeleton below, AI above. Before we wrap, a few pitfalls. 1. Don't optimize too early. When you've got one user, don't build the millions of users architecture. That's digging your own hole. 2. Make the web tier stateless first, then talk about scaling out. If state sticks to the box, adding machines gets you nothing. 3. Don't come out swinging at database optimization. A lot of the time, add a load balancer and a cache first, and the pressure on the DB drops on its own. 4. Don't run any tier flat out. Keep headroom and scale on utilization. 5. The cache is your lever on reads. Don't be stingy about adding it. It decides whether your database fleet is 1 machine or 10. Let me weld it into one line and close out Season 2 with it. Scaling to millions is walking this ladder, one rung at a time, chasing the bottleneck and moving it out of the way. All season, we started from order of magnitude intuition and designed Twitter, a web crawler, a social graph, a KV store, a sales rank system, and Mint's finances. And today, we fit all those parts into one diagram that grows. And AI, from start to finish, isn't here to tear your architecture apart. It's a new tenant moving in, into rooms you built long ago. Next season, we'll dig into these new tenants themselves. A RAG, agent platforms, inference services, vector search, LLM gateways. AI native system design. Thank you for coming all the way through this season with us. See you next season.